So that is that. So as we come together today, this is our third lesson in a series of 4 on algebra. And I just want to quickly remind you of what we did in the previous lessons. So in the first lessons, we were mainly translating into algebra. So if you go back and watch that lesson, you'll notice a lot of it is turning from English into algebra using the language of variables. So we might say something like, if you add a of something to 2, then we got an expression like that. So that was the first lesson. The second lesson was about subbing into algebraic expressions. So something like, if I gave you an algebraic expression like this, and I said to you that d was 10, then you had to know that 2d literally means 2 times d, so 2 times 10, and sub that 10 in. And then the final answer you get was 23. So that was kind of a quick review of what we did in the last 2 lessons. Okay. What are we going to do today? So in today's lesson, I'm going to give you a little bit of a preview at the very beginning. Can you identify unlike and like terms in algebra? So we need to talk about what is an unlike or like term. And can you recognize and simplify like terms? So that's another thing we're going to do. And then, do you know what a term, expression, and equation is in algebra? So at the beginning of this lesson, let me start by just describing what a like and unlike term is. So let me, if I give you 2 terms like this, 2x and 3x. In algebra, we say these are like terms because they have the same variable and that variable has the same power. In this case, it's going to be a power of 1. So when we have like terms, we can add and subtract them. So in the previous lesson, we actually did this. We said 2x plus 3x, that will give me 5x. However, if I said to you, are 2x and 3y like terms? I would tell you they're actually not like terms. These are actually unlike terms. And the reason they're unlike terms is that the variable names are different. This term over here has a variable x, and this term over here has a variable y. And so we can't actually add 2x and 3y. So this is going to be an important idea today. As we practice throughout the lesson, can you see when there are like terms? If there are like terms, you can add and subtract. If they're unlike terms, you can't add and subtract them. Now, that's the one thing that we need to bear in mind. Okay, why can't it be 5xy? Okay, we'll talk about that in a moment, actually. So, well, let me just do an example. What if I said to you, and I want you to answer this in the chat, if you've got 5xy and you've got 5x, now each of these expressions are called algebraic terms. If you think these are like terms, give a thumbs up in the chat. If you think they're unlike terms, give a thumbs down. I just want to see what we think. So thumbs up if you think these 2 are like terms, thumbs down if you think they are unlike terms. This is a bit of a tricky one. Okay, so I see that there's a little bit of mixture, but most of you are saying they're unlike terms. And the reason they're unlike terms is that the variable in this case, it's sort of like a variable that's together. This term has a variable xy, whereas this one over here only has a variable x. And so we can't add and subtract these. These are unlike terms. Let's try another one. What about if I have 5a and 10ab? If you think those are like terms, give a thumbs up. If you think they're unlike terms, give a thumbs down. Just want to make sure we know how to do this first. Okay, well done.
Well done, my people. Ah, you guys are doing awesome.
So even though they do have an a in common, the variable here is a, whereas the variable part here is ab. And the only way you have like terms is if you have the same variable and the same power. Let's do one more. What if I said to you, this term is a, and this term is 3, let me draw that again. This term is 3a squared. Give me a thumbs up if you think they are like terms. Give me a thumbs down if you think they are unlike terms. Okay, now I'd love someone to come and explain. Okay, so I can see this is getting a lot more debate. Yulinda, can you see how students are a little bit unsure of this one?
Yeah, me too. You know, everybody's like, oh, what's going on? Come to us, anyone. Woo, I see hands up there.
I would love for a student to explain to us why they think that the true answer is these are actually, well, actually, let me ask a student to help us. Who would like to give us an explanation? Okay, so Tando, I'm going to try and unmute. And if you could maybe tell us why you think these are not like terms.
Because of the squared answer. The first one is just a 1, and then the other one is a squared.
Yes,
Ooh,
exactly
well
that.
done.
So the problem is, thank you, Tando, that was fantastic. The key issue is that even when the variable is the same, the powers also have to be the same. And so these are, in fact, unlike terms. And when we think of unlike terms, guys, we cannot add these. If terms are unlike, we cannot add or subtract them. Okay, that was fantastic. I really want to commend you guys. We've got a good base for the rest of the lesson. What I want to do is now move on to just, actually, before I move on, let me make sure I explain what a term, expression, and an equation is. So in algebra, there's certain vocabulary that just gets thrown around a lot. And I just want to make sure we know some of the vocabulary, and then in the lesson today, we'll practice it. If I just write one thing like this, a lonely 3a squared, or 3a, in algebra, we would call this a term. It's just a term, one term standing by itself. If we have, well, if we have a couple of terms together, say something like that, we call that an expression, an algebraic expression normally, but just an expression. So in some ways, the first one could also be called an expression, but it's only got one term, whereas the second one is an expression with 3 terms. Now, there's something else that's quite commonly mentioned in algebra, which is an equation. And I would love, again, a student to maybe suggest how is an equation different to an expression? Okay, Amakle, I'm going to unmute you. Could you tell me how is an equation somewhat like an expression, but also a little bit different?
Afternoon, sir and ma'am, and everyone.
Hello.
The difference between an expression and an equation is that an expression does not have an equal sign, but an equation does have an equal sign.
Ooh,
Perfect.
go down.
So if we wanted an equation would have 2 expressions that are linked with an equal sign. Okay, so today in the lesson, you will see me refer to terms, expressions, and sometimes, maybe in the last lesson, we'll talk about equations. But just to make sure you have an idea of kind of the language about these things. All right, let us go and do some questions now.
Ah, my people. Y'all are doing really good.
We're doing good. Okay. What I want to do now is I want you guys, I'm going to do the first one for you, and then you're going to do the second ones for me. So this is called a simplification question in algebra. And I am given an algebraic expression. In the first one, I'm given an expression with 4 terms. And when I look at these 4 terms, and I look and I see, are any of them like terms? And some students like to highlight like terms. Some students like to draw a line underneath. It's up to you. But I am going to identify that those 2 with a blue line underneath are like terms. And those 2 with a red line underneath are also like terms. And what I see is I have 2 different types of like terms. And so in order to simplify, what I'm going to do is I'm going to add the ones that are like. So the 3a and the 4a in algebra can be simplified to 7a. And the 2b and the 4b can be simplified. Now, there's one sneaky, tricky thing. What is the number in front of the b? Can somebody put that in the chat? What's the number in front of the b? And for bonus points, you guys are so quick. So it's 1 in front. And so 2b plus 1b is going to be 3b. For bonus points, what's the fancy word for the number in front of a variable? I haven't mentioned this yet, but I want to throw it in. There's a fancy word for the number in front of a variable. If you can raise your hand or you can put it in the chat. Okay, Princess, I'm coming to you. What's the word for the number in front of the variable? Can you hear me, Princess? I'm trying to unmute you.
Princess, you will receive a small block that says unmute. Please click on that block. You just have to click it so you can talk to us.
Okay. I think maybe Princess is having a few thingy issues. I see lots of hands and lots of things in the chat. The fancy word is the word. Oh, is that Princess? Is that you? No. The fancy word is coefficient. And so we call the number in front of the term the coefficient. So the coefficient in front of b is 1. Okay, fantastic. Now, guys, what I want you to do is I want you to do for me b and c. I want you to simplify the algebraic expressions b and c, and I will leave my example up to guide you. Well done, Sivanati. I see you got that as well. And over to you guys. See if you can simplify these algebraic expressions. Okay, so I see lots of answers for B coming in. Now, that's fantastic. I love how my students are being active in the class. I love how when I look at the webcams, I see people writing down, sitting at a table. These are all very good signs, everyone.
Oh,
very good.
They are awesome. They are my awesome favorite class.
And then okay, so I've put the answer for B there, and I'm going to give a little bit more time for C. So Fareed is asking, I wanted to ask if we first group the like terms, then add. Okay, so Fareed, the main thing is you need to make sure you know which ones are like terms. It's not wrong to write another step. So in 3, you may be saying, look, I can see the G's are together. Should I write this question as G plus G plus 8a plus 2a. It's not wrong to do that. And sometimes when the expressions get more difficult, it helps. But at this stage, I think you can just notice which ones are like terms. And so in this case, the answer is going to be a g and a g. Well, the coefficients are hiding. I call them phantoms. 1g and 1g is 2g. And 8a plus 2a is 10a. Okay, fantastic. That was looking very good, guys. And in fact, it was looking so good that I'm going to ask you to do, okay, I'm going to ask you to do, let's do the top 3. Oh, you can't do, okay. Let me quickly zoom in a little bit. So what I want my students to do, I'm just going to make it bigger so I know, otherwise I know I'm going to get questions in a moment. In fact, I'm just going to do these 4. So everyone is going to be working on, in fact, let's just do these ones. Let's do J and K and see how it goes. If you're feeling very comfortable, you can go on to M and N, and then I'm going to work on C on the side here because there's some students who are asking questions about that. Okay, so everyone else, J and K, off you go. And then I'm going to explain question C while that happens. So, Matapelo, do you want to, if we look at C, right? So let me erase everything. Oh, can you hear the dogs outside barking? If we look at C, we have to recognize where the like terms are. And so I want to say that the G's are like terms. The other like terms are going to be 8a and 2a. And if you think about what you get when you go 1g plus another 1g, so basically when these are 2 are added together, you get 1g plus 1g, which is 2g. And then when you add 8a plus 2a, you're going to get 10a. I hope that helps. Does that help a little bit? I don't know if you want to raise your hand and ask the question in person, but I think that will help.
I think you wanted to answer the question, but now at least we all understand it. Yeah, now we all understand it. Thank you, Peter.
Pleasure. So yeah, you'll notice that these are a little bit more tricky, guys. So I am pushing you a little bit more. Murdy raised your hand. Murdy, do you want to, let's unmute you if I can find you. Yeah. Hi, Murdy.
Yeah, hi, sir. You said like G plus G is 2G, but at my school, we do it like, isn't it, even if we don't see like a power, we know that it has 1. So when we do it, we don't say 2G, we say G to the power of 2, which is easier.
Be careful. Be careful, Murdy, be careful. Okay, because actually 1G and 1G are like terms. They're the same type of thing. And when you add them, you get 2G. What you're talking about is something we're going to talk about later in the lesson or in the next lesson. And that's when you multiply. When you multiply 1G by 1G, or just G times G, then you get something called G squared, which is something completely different. Does that make sense, Murdy?
Yes, sir. Thank you.
Yeah. Because what we're practicing is addition and subtraction now, and what you're talking about is multiplication there.
It's a very common,
and
thank you for that. At least it helps.
Atlikhan, can you hear me? How's it going?
Yes, loud and clear. Good, thanks.
Can I help you with?
I just wanted to answer K or J, I don't know.
Okay, for which one?
J.
For J. Do you want to answer for J? Go ahead. Go ahead. How do I do it?
So first we need to select the like term, which is 3x plus 5, which becomes 8x.
Okay.
And then you collect 6y minus 2, 6y minus 2y, which is 4y.
Well done. You did so well there because you noticed the minus. So when you go 6y minus 2y, you have to get the 4y. So well done, Atlikan. Could you help us with k as well?
All right. So we connect the like terms again. So we say 6n plus n, which becomes 7n, since there's an invisible one.
Okay, perfect.
And we
Yeah.
say negative s plus 11, which is 9s.
Okay, this is getting trickier. Minus 2s plus 11s. Did you, and you, I heard 9, hey? 9s.
Yes. Minus 9, yeah, plus 9s.
Yeah,
9s.
because when you're on the number line, if you start at minus 2 and you add 11, what's going to happen is you have to go up by 2 to get to 0, and then you keep going for another 9. Perfect. Thank you so much. You were really great. I'm going to ask if there are any questions about that, or if students, for the rest of us, can we go on to M and N? And then any students who have questions, if you could just raise your hand. I'm going to go to Matapelo. Or at least I'm going to try to. Don't know if I got you. Tatenda, do you have a question? So remember, guys, the rest of us are doing M and N.
Tatenda, you can unmute if you have a question, because I just ask you to unmute. So you just have to click on that button, okay?
Machle has a question. Okay. I'm going to go to Machle if she can unmute. I'm trying to unmute you.
I think Tatenda is unmuted.
Yeah.
Oh, okay, Tatenda, you go first.
Yes, sir.
How's it going?
I'm good, sir.
What's your question?
Sir, when you say number M,
Yeah.
3AB minus 2AB.
Okay,
Do
be careful.
you first take 3AB to the back?
Okay, what I would suggest is, if you like, you can write up the like terms together first. So you can rewrite it as 3a plus a, and then you can write minus 2b minus 5b. That is an in-between step that may help you see which terms go together. Then once you've done that, you will see that 3a plus 1a is going to give you 4a. And then when you've got minus 2b and you take away even 5 more b, what do you think you're going to get, Tatenda? Are you with me?
1b.
Okay, so think about this on the number line. If you're at minus 2 and you take away 5 more and you're going to the left, where are you going to end up?
At -3.
Okay, -3. Now imagine if you take away 5 more. So if you go at -2 and you're going to take away 5 more from there, where would you end up?
-1.
Okay, not quite. You're actually going to end up at -7, huh? Think about this.
Yeah.
So -3, -4, -5, -6, -7.
7.
So that's why you get minus 2b minus 5b is going to be minus 7b. It's almost like you took away 2 bananas, you took away 5 more, therefore you've taken away 7 bananas. Okay.
Oh, yes.
All right. Would anybody like to do n? Is anybody willing to help us with n? I'm going to go to Jabile. Oh, wait, no. Mosa, can I come to you? Will you be able to help me? Okay, Mosa, can you help me with n to get me started?
Yeah. What the heck?
Okay.
And there's -4.
Okay, -4, what? So you have 2x. So you have 2x and you've got minus 6x. What does that give you together? So 2x minus 6x. Okay, you're going to get minus 4x. Okay. Who would like to help us? Okay, so minus 4x, perfect. Now the second part, I have minus 2y, and then I'm adding 5y to that. So in the chat, everyone, tell me what you get. I want to see for everybody to see if you're getting this. Minus 2y plus 5y. What do you get when you take those two like terms and put them together? Okay, you don't get 7y. So think about when you got minus 2 of something, if I've lost 2 of something, and then I find 5, what do I end up with? So think about the number line. If you're at minus 2 on the number line, and you add 5, where are you going to end up? Okay, you're going to end up at 3, so this is going to be 3y. So minus 2x, sorry, minus 2y plus 5y gives me 3y. Okay, now I think we need a bit more practice on this. I don't know what you think, but I think a little bit more practice.
Yes, and also I think it's because of the signs that we can maybe, you know, prove our answers using a calculator also if we have to.
Yeah, let's do 2 more just like this, just to make sure we are really mastering this. So in this question, what I want you to do is I want you to do the following, guys. So follow these instructions exactly. Go through and mark which ones are like terms. So for L, put a little mark or a block or whatever you want around the ones that you think go together. And then what I want you to do is I want you to actually write out those for a second line. So make a second line where you put all the ones that go together near each other. And then the last step, I want you to add or subtract the like terms. Okay. Now, while you're working on that, I will take questions from students. So raise your hand and I will take questions from students who would like to ask a question.
Sir.
Okay. Okay. Yeah.
For the first one, for the exam, for the activity you previously did, the first answer, would it not be 6y plus negative 2y? Because I'm confused.
Okay, let's just go back. I need to 6y plus negative 2y. You end up with the same answer. So if you plus a negative, it's equivalent to the same as taking away a negative. So you would get exactly the answer. Okay.
Thank you,
what
sir.
I'm going to do is I'm going to go through L in detail because I can see a couple of students need a bit more help. And I'm going to go through L exactly kind of as I was describing. So first I look to see what are the ones that go together. And I'm going to use a highlighter now. Oh, what happened there? Sorry, I lost you. I'm going to use my highlighter. So I'm going to get 2A. I have an A, and those are the ones that go together. Then what else is going to go together? I think that 3B and 3B are going to go together. And then the last thing that's going to go together is going to be my -2 and my +4. So at least now what I've done is I've spotted my like terms. So I'm going to rewrite them so that all the like terms are next to each other. And maybe I'll even say, I could say -2 +4. And just for some extra vocabulary, guys, when there's no variable, when there's just a number, we call that a constant term. So -2 and 4 are called constant terms. So now what I have to do is I have to simplify this line in between. And so what am I going to do now? Well, I ask myself, what is 2A plus 1A? So 2A plus 1A is going to be 3A. What is 3B plus 3B? It's going to be 6B. And what is -2? So think of where you are on the number line, -2, and you add 4. So you go up by 2 to get to 0, and then you go up by 2 more. And so your final answer should be 3A plus 6B plus 2. Now, using what you've learned in this question now, and that example, I want everyone to try and do O and use this method. So write down first, or first identify which ones go together, or what we call like terms. Then write down a second line, and then do it where you put them next to each other, and then a final line where you do your summarizing. Okay. Okay, I'm going to come to students who would like to answer for the last one. I'm going to give you a chance, so please put your hand up, and then we're going to go from there. Okay, who has not, Yolanda, who has not had a chance tonight, who's got their hand? I think Malusi. I think Malusi can help us if you're willing. Malusi, can you hear me?
Yes, sir.
Can you help me with O? Can you give me some guidance?
Sir, so for O, you would find your like terms first, so it'd be Y and 3Y, and then it would be 4M and 5M.
Okay, let me just do that quickly. So first of all, you've identified. Now, what are you going to do next after that?
Sir, would you add Y and 3Y and make it 4Y?
Okay, so now be careful here. If you look at what we've
negative 4Y, negative 4Y.
Okay, hold on. If we just wrote them out just as they are, would you agree that we have that? Just take a moment. All I've done is I've moved the pink ones next to each other, and I've moved the yellow ones. Would you agree with me so far, Malusi?
Yes, sir.
Okay, now, here's the thing. I haven't written anything new. You're right in saying that, for example, the Y has a plus in front. But what else does the Y have in front of it? What number?
It has a 3.
It actually has, doesn't it have a 1?
Like a 1, yes, the coefficients.
Okay, exactly. Now, what I want you to do is I want you to help me simplify these like terms. If you have 1Y and you take away 3Y, what are you going to get?
Negative 2Y.
Perfect. Absolutely perfect. Okay, now the next one, if you have negative 4M and you take away 5M, what is that going to simplify to?
Sir, wouldn't it be negative 9M?
Perfect. Because can you see, you took away 4M and then you took away, it's like if you took away 4, what starts with an M? If you lost 4 Maseratis and you took away 5 more Maseratis, you've lost 9 in total. And
yes,
so the final expression is negative 2Y minus 9M. And that looks a lot simpler than what you started with. And yet it is exactly equivalent to the original. It's just been simplified.
Yes, sir. But sir, I have a question. With like 4M and 5M, would you, because you know, like in algebra, most of the time, like a negative and a negative equals like a positive. So would you do that for 5M and 4M?
Okay, this is really, really important. I want everyone to listen. You've asked such a good question, Malusi. When you are adding and subtracting, you don't necessarily get, like 2 negatives don't necessarily make a positive, right? It's only when you're multiplying or dividing that you get that. And what I'm going to do is in the next lesson, I'm going to focus on multiplying and dividing to show you. But at this stage, when you're adding or subtracting, if you always think of the number line. So for example, if you have 1 of something, you can visualize that as being at 1 on the number line. So when I think of 1, I'm thinking of 1Y. Now, if I take away 3 of those, where am I going to end up on the number line? Well, I take away 1 to get to there, and then I have to take away 2 more. And so what I end up there is I end up at minus 2. And that's why my answer was minus 2Y. Does that make a bit of sense?
Yes, sir.
So I want you to watch out. We will do multiplication separately, but for today, all I want to practice is adding and subtracting like terms. Okay.
Okay. Thank you,
fantastic.
Sir.
All right. Now we need to do a brain break. So I want everybody to stand up and do your favorite stretch. So stand up, cameras on, favorite stretch. Yolanda, I want you to look out for the people with the best form. And then we are going to do a brain break in a moment. I just need to turn my lights on.
Let's go, guys. It's good for
I
your
want to see you stretching. I want to see you stretching. Show me that stretch. There we go. Oh, yes. Think of all that stress from the day. Get it out. Oh, doesn't that feel good?
I needed it.
I know your body's grateful. It is. In fact, oh, I need a hamstring stretch. So before I reveal, well, I'm going to reveal the brain break. And I want everybody to, while they're stretching, start to think about the brain break. And I'm going to stretch out my hamstrings. Yo!
Melo, did you stretch?
Come on. Okay, so I see some answers coming in.
Melo, I don't see you. You're stretched there.
Come on, you can do it. Stretch out your life. There we go. Kaya Lichle, I can see a quality stretch there. Quality stretch going on there.
Matimba, I want to see your stretch. Let's go.
Let's go. All right, now, once you've had a quality stretch, I want you to come to the brain break and I want you to give it a go. I see a lot of students have put that they get 10 for the triangle, which you are absolutely correct. And then a few students have even said that in a circle is 5. Notice how you're using equations, guys, because there's an expression on one side and an expression on the other side. Okay, what is a half triangle going to be? It looks to me, and then I want the final answer at some point. So it looks to me like students are saying that each half triangle is 2. And so the question is, guys, what, and girls, what is the final answer going to be? So a half triangle is 2. Yes, I totally get you on that. The final answer, be careful with BODMAS. What has to happen first? Is it the multiplication or the addition? I think with BODMAS, 5 times 2 needs to get done first. And so that means I have 10 plus 10. And so you correct Fareed and you correct Sivanati. It is 20.
Well done, guys.
Right. Well done. Shout out to you all. Also love the enthusiasm. Also notice, guys, you're actually learning about equations before we've even got to equations, because every time we do this is an equation. Okay.
That's awesome.
Fantastically done. Okay. What I want to do now is I want to go back to our practice questions. And I know we need a bit more practice. So let me select a question that I think is appropriate. I'm not going to do that. Okay, let's do this. So I'm going to do a different type of like terms problem. So I'm going to do an example on the left, and then you guys are going to do the ones on the right. So in the question, it says, write down the perimeter of the shape below. Now, perimeter means what is the distance around the outside? So the perimeter would be if I walked around here, and around here. So I'm going to actually use the letter P for perimeter as a placeholder. How very algebraic of me. So the perimeter to me looks like it would be 2x plus 2x plus x. Now, what is the perimeter going to be? Well, luckily for me, these are all like terms. And I also know that the coefficient in front of the x is 1. And so if I go 2 of something plus 2 of something plus 1, the perimeter is going to be 5x. Okay, so that is the example. What I want you guys to do is I want you to find the perimeter for A and B. And once you are done, pop it in the chat or raise your hand, and you can then amaze us all. That would be fantastic.
Let's do it, guys. Let's do it. We
Let's
can
go.
do it. Amat, is that a question? Oh, we're done. Okay.
Mhm.
Guys, question A is quite interesting. I'm looking at it and I'm like, whoa, I get
I know.
it.
You know, I wonder if the students know what sort of shape that is.
Oh,
I suppose
yeah.
it's almost like a rectangle that fell over or
But it's
something.
not. No. It's not a right. Oh, no.
Bonus points in the chat if you can, you'll get a shout out from me. It's not a rhombus, but you're close, Vukile, because a rhombus has equal sides. Oh, sorry, I just, so what happens is I've got an automatic setting that changes the lighting on my computer. So as it's getting dark, it goes dark. But
It's a cool setup.
yeah, it's to save my eyes. So it's definitely a quadrilateral. I suspect this is a parallelogram. It doesn't matter for this question because we're talking about perimeter, but I think A would be a parallelogram and B is a rectangle. Okay, so what do we think the perimeters are going to be for these ones? So who would like to help me with A? Raise your hand and you can help me out. Kanyesile, coming to you. I'm trying to unmute you if you can help us. Try and unmute yourself, Kanyesile. Can you hear me? So Jabulile, all I'm going to do is I want to know the perimeter of the shape. So what is the perimeter of this? But it's in terms of variables. And so what you have to do is the perimeter is adding up all the distances around the outside. I'm going to come to Utumalang. Utumalang, if you can help us out on A or ask your question. I'm unmuting you. Yeah. How's it going, Utumalang? Utumaleng, rather, sorry.
I think A is 22.
So tell me what you did first.
So I said X plus 9.
So I think what I'm hearing at Tumaleng, although the audio is not great, is you wrote out, you added all the sides together. Is that what you did? And the next,
I said X plus 9, and since there's 1 in front of the 9, in front of the X, I said X 1 plus 9, and then I took them all, and then I said 10, and then it's X plus 9, and it's 2 of them, and then 2 X's, so I said 20 plus the 2 X's would equal 22, so.
okay, you're close. There's one important thing I want to point out. Do you agree with me, Tumaleng, that the X's are like terms, they belong to the same family, and then the 9s, they're what we call constant terms. And actually, when we're simplifying, we have to put all like terms together. And so there's something, I agree with your first step, but this next step, we need to handle it more like the other ones. So I'm going to go to Sibongo Kuchle. If you can unmute, could you help me?
Yes, sir. Am I unmuted?
Yes, you are. Go ahead. What do I have to do next step?
Okay, sir. I said 9x plus 9x plus x.
Oh, yeah, 1x you mean, huh? So it's 1x.
It's 1x and plus 1x. Then my final answer was 20x.
Okay, almost. Here's the thing I want to point out. If you look at these terms we're adding, I can only add the yellow ones with the yellow ones, right? Because they are like terms. How many x's are there? I'm going to count them. 1x plus 1x plus 1x plus 1x. That is going to be 4x. Think about it. If you got one of something and another one, you get 4x. Now I'm going to add what I call the constant terms, the ones that are numbers. What is 9 plus 9? It's just going to be 18. And so the perimeter of this is going to be 4x plus 18. Now, what I want is I'm going to give you a hint for B. For B, because this is rectangular, the opposite sides are going to be equal. Now, what I want you to try and do is use the same method I just did to try and answer B. Does that help a little bit?
Yes, sir. I already have my answer for B. Should I say it or should I give another?
Start with the first step. What do you do for the first step?
Okay, so because both sides are equal, I say 3y plus 3y. I group the y, then I said plus 2x plus 2x.
Okay, so you've even done one step in a go. Okay, then next bit, what do you do?
I got 6y for 3y plus 3y plus
these two,
4x from 2x plus 2x. So my final answer was 6y plus 4x.
Yes. Now, what we sometimes do, that was really good. What we sometimes see people do is they like to write algebraic expressions in alphabetical order, and it's completely, you did it perfectly. Just sometimes you'll see people write 4x plus 6y because of the alphabetical order, but that is completely perfect. Okay, and generally in terms of algebra grammar, we do try and stick to that convention. Okay, but that was fantastic. Okay, now I'm not going to do that one. I want to end with one. Oh, sorry, that was a bit abrupt. I want to make up, how much time have we got left? Let's do one more question like this, except I am going to, I can't do that. I'm going to make one up for you. So if I give you, let's ignore that one there. So we're going to end with this, guys. I want you to find me the perimeter of this shape. This shape is going to be another parallelogram. And on this side, it's going to be 2x plus 3. And on this side, it's going to be 4y plus 2. I want you to finish today to find me the perimeter of this parallelogram. And the opposite sides in this parallelogram are equal. Okay, over to you guys. If there are questions while students are working on this, I will come to you. So who has a question or a comment? Matapelo, I'm going to unmute you. Matapelo, can you hear me?
Matapelo, remember you have to press on that button there on the block to talk to us, okay?
Sir, I can't see the full shape. Okay, I'm going to zoom in a little bit.
And also you can put your questions on the chat. Also, we are watching over that also.
Yeah. And so what I said previously is I'm just going to write out because remember, perimeter is the distance around the outside. And so all I've done is I've started by adding all 4 of these algebraic expressions together. Now what I want you guys to do is I want you to hunt for the like terms. And then also I just remembered, Yulinda, that today is a poll day. And so we will do a poll before we finish off today.
Yep.
Okay, so I'm going to go hunting for like terms. If only I had enough colors. So I think I found my like terms. And now what I need to do is I need to put them all together. Who would like to answer or help us with this? Amakle, I'm coming to you. Help us out. Can you hear me, Amakle?
Yes, sir.
What do you get?
So you'll say 2x plus 2x, which is 4x.
Yes, perfect.
And then you say 4y plus 4y.
Which is?
8y.
Yes. And then?
Then you'll add 2 plus 2, which is
Yes.
4.
Yeah.
And 3 plus 3, which is 6.
Almost perfect. What's the last thing you can do to simplify even further? Aren't 4 and 6 also like terms?
Yes, they are. So it's 6 plus 4.
And what do you get then?
10.
Perfect. Absolutely perfect. So you get 4x plus 8y plus 10. Now that was a tricky one, guys. That was a proper tricky one. And in the next lesson, we are going to carry on with this type of thing. Okay, but before we finish off tonight, because we have to finish off now, I would really appreciate it, guys, if you could answer our poll question. And then I really look forward to seeing you on Wednesday when we will continue with our algebraic journey. And yeah, well.